Hello everyone. Before I start, I want to ask you about questions. The first one question is, who have been working with Java ME? It's like, here I took this form. It's it's a very interesting form, and it's also mobile development, so it's also our field. So don't, yeah, and you know, like I also took another form. It's here. So, and if we think about creative UI for this form, actually right now it's pretty similar. We use the same imperative. We use the same imperative approach for create a UI. So today I want to talk about opportunities for React Native developers, for Flutter developers, and also I want to. It will be very good to know for native mobile developers, for Android, for iOS. So I think we can start. So let's start from challenges. What kind of challenges the mobile developers have? So the first one is dynamic UI. As I show you this iPhone X, it has tons of UI elements. If I show you this phone, it's actually one, I don't know, for example, if we get a contact list, it only has a contact list and navigation buttons like back and close. So there is only the main one component, so it's very simple to create a UI for this type of phone. And here we could see an evolution of displays. 20 years ago was released a very popular and very famous cultural phone. It was Nokia with monochrome display. And right now you can find a flexible display with two devices. They are really big, they were rich, so you and developers have to think how they could synchronize these displays, how could they use it. So it's actually, if you know, recently Google announced they are not so interested in development tablets because mobile phone goes to very big displays, and flexible device is a good example. Let's understand what the UI workflow right now is when you create a UI. So first of all, you have some kind of initialized UI elements. It could be some empty state, something like that. Then you go to server, you fetch some data, you try to put the data in view model or something kind of that, or directly to try to synchronize your data model and your view model, and then you update UI elements. If we talking with this example, it's classic material design example by Google. So you see, let's imagine how our mobile developers, native mobile developers, are developing right now. Though they get, for example, transactions, and they put to list contain these transactions. And if we have some new transaction, we have to synchronize, we have to update our cycle view. And in the same time, we have two source of truth. So what is source of truth? It's the thing that own data. So our list own data and our repository own data. So, and very often, even with to-do list, you can edit your one item in to-do list. And now it's very difficult to create an app that you always have that updated data. And it was a first challenge. But also we have the another challenge that's actually very close to developers, not to clients, but to developers. We have to write a lot of code. For example, I found some interesting facts, and also I go to the deep into the source code, and I feel like Vue class on Android has 29,000 of line of codes. Your recycle view, it's a component for display a list, has 12,000 of code. Even text view just show its element that must show a text, has 8,000 of codes. And you know, like the base class for widget, it's a view on Android. It has from out of box features like animation, scroll, drag and drop, on state, and other many features. And you know, like when you initialize your application, you initialize these features even if you don't use it. So it's really prevent you to have a very fast UI. It's very difficult to create a fast UI with a widget with 28 line of codes, 2,000 lines of codes. And also, there is a very good example of Spinner. It has 4 levels of inheritance. So, but does it should have so many inheritance, some level of inheritance? Maybe it's something not good with design. Maybe we have to use Compose instead of inheritance. So let's go to the theme that help us to solve this kind of problems. So let's say we have some screen. So and everything that you see on the screen is you have a screen and it's a tree. So every UI is a tree. And as we talked, when we have several sources of truth, so your list or your repository, your application data, owned data, so you have where you have the same data in different places. So let's think like we want only have one single source of truth. So one place where we own data, one place. We don't want to store our items in a list. We just want to render it. So we just want to give a state. So it's your data. We want to render a tree of UI. So it's a list, for example. And we want to return a rendered UI. So here I try to show you on a very simple example. We have some very simple to-do list where we have 2 items, 1 button. So the tree will be like you see on the left corner. So on the top is a scroll view. Then we go to container of items. And then we go to text items. And it, for example, in many frameworks, it could be done with preorder traverse of tree. So it could be recursively. It traverse recursively. So first of all we try to build this tree. So and this is a runtime. So runtime, when you hear runtime it's a scene that built your UI tree and manipulate with this tree. When you read something about UI toolkit, or when you read something like React is just a UI framework, yeah, it's really just only a UI framework. So we have a runtime. It's our components, our we built our UI with J6, and we have our runtime. In React Native, it's Yoga and widgets on native platforms. It could be UIKit or Android widget. So UI Toolkit does measuring, layouting, and rendering. It actually Vasily touched this topic, and he told like, oh, we go recursively on the tree, we doing measuring. So it seemed like when parent told how many space you can take. It do layouting. It's try to positionize items on the surface, and you rendering. So you just call a function that draw on canvas. So if you compare with previous tree, you see like we just have some nodes: scroll, view, button, text. But here, after measuring, layouting, and rendering, we have widgets with data. So let's go to discover what kind of declarative UI right now is on the Android and the iOS, because there are actually a lot of UI frameworks, declarative UI frameworks, but some of them are not official. What does it mean? It means they use their own runtime, but they use old UI toolkit. So, for example, like React Native. React Native use a runtime, but React Native use Android UI toolkit. So you see, like, if you have very good performance on the runtime, we have a bad performance with UI toolkit because we use imperative UI toolkit. And even this kind of declarative UIs like litho, component kit, texture, they try to do many good things, and they do it, but they use old UI toolkit. And 1 month ago, Google, I cannot say like released, but they represent some proof of concept of new runtime and new UI toolkit. It's a Jetpack Compost. And only several weeks ago, Apple also released a SwiftUI. It's kind of similar with Jetpack Compost. So today we are only discuss about SwiftUI and Jetpack Compost because it's a completely new framework with runtime and UI toolkit. So what is the reaction of community? I found this kind of popular tweet that say, wow, Apple released SwiftUI, Google released SwiftUI. Wow, it's credible because people who already knows React or Flutter, they very familiar with kind of concept of declarative UI, of single source of truth. So actually, it's very similar what we are doing on React Native. Let's take a look what it is Jetpack Compost. Jetpack Compost is wrote on Kotlin, and it's fully Kotlin framework. So you write your UI with Kotlin, and declare UI with Kotlin, and its runtime works on Kotlin. It's single source of truth. It's completely brand new UI toolkit, as I told, and it's unbundled from platform. What does it mean? It means if you have some old Android device, it will support, Jetpack Compost will support this device. So actually, in the future, we could increase a rendering on this old device with Jetpack Compost. Let's go ahead to understand why it works faster. Everything is a widget in Compost. Yeah, it's very similar to Flutter. Yeah, everything is everything. Like on React Native, you know, we have a style and we have a padding. So we can set a padding in React Native, or we can use a flexbox with style. So in Compost, everything is a widget. So it's a hello world. Just want to show how it looks. So it's one function. It have annotation composable. And in Kotlin, if you don't know, if you use only JavaScript in Kotlin, it's you can eliminate return. So this function return text. So this function return text function, and you pass as input text. If you are from React Native, it's a props. So you pass a props text with hello world. So it's only one function, and as you see, it's rendered only hello world, so nothing else. Let's go to the deep and understand how it works, how they do this kind of framework. When we have a composable annotation, it tells a compiler to generate a boilerplate code for create intermediate representation. So you write just composable function, compose Kotlin plugin in Android Studio runs, it parse and it validate your UI, and it for every composable function, so it add emit and add group. So we will go ahead and understand what is it. So what is actually emit? Emit, it's a function that add our composable function into the node of intermediate representation. It's very similar to virtual DOM in React. So we have emit node and we have use node. So if it's not already in intermediate representation, we don't have to insert and we don't have to emit in our tree. If we don't have this node, we call emit node. And there is a class composer Kotlin. It's a file that's responsible for holding your tree. So there is a separate class compose. It's held in the tree. It recompose tree, so it's re-render. It's try to find a diff. It's called rendering. Let's go to a very interesting and very problematic topic with declarative UI, and it's seen that very discussed and it's very difficult to understand how to render your UI. What, like, there is with declarative UI, you have a problem. You have a tree, you have some kind of UI, and you update some data, and how to render your UI. So how to find a div, what changed, what to replace. And Compost use under the hood the concept of positional memorization. What is it? If we want to simplify, it put all nodes in the same order they was emitted. So it's if you compare with I don't know, like with React, if you know hooks, if you call fx use state, it also put in this it's very important to put in the same order. So cache very depends on order. So Compose do the same, but you know, like what if we move some item on, if you move some item on from our screen to, I don't know, if we remove something, so we don't want to, and we want to understand that we have to reuse if order change it, how to know and how to restore this node. So they actually introduced some method, as you saw on the previous screen. It's group. What does group do? It's actually add some key to your node, and it helps to understand what. So every node has a key, and if we see a difference, we know if you see that there is in this place there is no key that it was. So we try to find where this key was in other part of tree. If we didn't find it, we emit. If we find, we reuse it. So it's every node has a key, and group it helps to create some kind of tree cache. So it's you have like a tree of key. If you're talking about rendering, it's very simple actually, but it will be changed. I think they told something about it. What they do, they give you a tree of composable function and put in frame layout. If you know Android, it's a very simple existing widget. So as you see, I took this from source code. So they call a composable function. They pass a composable function. It's actually your root. And they create a frame layout. And they attach a composable function, your root function, to root and call compose. The funny thing about Compose, and it's maybe will be interesting for Vasily. They have in source code they have some piece of Dart code from Flutter, and I found a function copy with. It's existing function in Flutter documentation. So actually they are very inspired from Flutter, and they are aligned with what Flutter did. So actually it's Flutter, maybe like improved Flutter for Kotlin, with Kotlin and for Android. But actually in Compose there is no stateful or stateless. It's only stateless. So it's only function, and it's use effect. So it's like if you're talking about React Native, it's stateless function with hooks. Okay, let's go to the Swift and SwiftUI, and after that we will try to do some simple application, and we will compare on the left and the right side how Swift code, SwiftUI code, and other Jetpack Compose looks, because they are very similar, and we will see a difference. If you talk about SwiftUI, it's actually released, so it's has a very good documentation. I think very good, and it's also a completely brand UI toolkit. It's also a single source of truth. But you know, to compare with Jetpack Compose, Swift UI also only runs on iOS 13. So it's not there is any back compatibility with SwiftUI and old iOS platforms. It only runs on macOS, the latest one. And actually SwiftUI, it's kind of concept that will be used for all Apple devices. So I don't say that it will be cross-platform, but the technology and the principles will be used for the old Apple device, Apple Watch, macOS, and iPhone. And the very good thing to compare to Jetpack, SwiftUI has a hot reloading. It's where we really familiar with it in React Native. So you see, I type in something, and on the preview, it's render immediately what I'm doing. You know, if in React Native we only have hot reloading to only show what we did, but here we are. We can create a UI directly in Xcode and add it, wrap it, some component with containers, so we can create UI, declarative UI in Xcode. So it's very huge impact on working with declarative UI. And unfortunately, in Android Studio we don't have this, and in React Native also. Yeah, for using SwiftUI, you have to install the latest macOS, as I told, latest Xcode, beta actually. You only check, when you create a project, you only check, I want to use a SwiftUI, and it creates a template with Hello World. And you can start with official documentation, and it really took like 3 hours for you, and it explained about navigation, creating UI, states, many things, so it's very, very good. Hello World looks like this. So it's also very simple, but as you see, here is more boilerplate code compared with Jetpack. Because Jetpack have a compiler that generate with annotation. Here, like we have a body, you know, like we create a view. We confirm the protocol view, and we have to have a property body, and we put it text. But in composable, you only declare it. I want to use a composable function. I mark it with composable annotation, and it's do it all for you. That here we have to write. So actually, tomorrow, later we will discuss about disadvantages and advantages of this kind of technologies, but you really have to write more boilerplate code. So, yeah, I'm going to show you some examples. It's very simple. It's like very simple to-do list. Actually, I click on Say Again and add to the list item. The index only changed, but the title the same, still retains the same. So let's go to see how to add padding. In Compost, on the left side, you wrap your button, as we have, Say Again, with padding widget. On SwiftUI, as we see, we use a modifier on a widget. So, and in the Compose, you see like we create a edge insert, and we use only top. So we do a 15 top padding, and also do the same on the Swift, but we do this with modifier. If you go into the style, we see it's also different. In Compost, you have already predefined a widget, a composable function. It's a material theme, but it's in many times better than I was used on Android when I developed for Android. Because for material design theme, you have already defined typography and colors. So you can use, you can only pass something like I want to use a body style, I want to use H1, H2, so it's already predefined. So you don't have to think about XML, about attributes. So it's very, very simple. In SwiftUI, we also use for styling as for padding modifier. So we use a background modifier, and we pass a color green. Yeah, go to the layout. Actually, layout on Compost works looks very the same as on Flutter. So we have a composable function column. So if you want to, like in React Native, we in style defined, I know, like you want to use, we want to have a horizontal or vertical orientation of our component, but here we use a function column, and we, as input, we can pass to the column the alignment for main actions and for secondary actions. So here I pass a main actions alignment. So as Wathili had a talk, I saw like they also have the same name, main action alignment, when they use layout in Flutter. So in SwiftUI, we have actually very similar concept. We use a vStack. So we it's mean vertical stack. There is also edge, horizontal stack. So column, it's a V stack. Row, it's on SwiftUI UI is edge stack. Also, there is very good thing in SwiftUI. You can pass to edge stack input spacing. What does it mean? It's the space between your items. So you don't have to use padding for every widget. Like you can like where say like here said, I want to use spacing 15, and between my views there is a space 15. The alignment works differently, and in Jetpack Compose, in SwiftUI you use a spacer. It was very interesting for me how it works, and like it's a very difficult concept for Android development actually, because a spacer, what here is do, it took all free space from left side, and then I have two text, and the last one is space. It took the all space from right side. So like here like shift from left, from right, and our items is in the center. So it's very, very interesting and very like not so understandable for me still. But yeah, maybe I will be know what is it. If you're talking about state in Compost, it's very similar how in React we use. We just call a function state, and we pass a default value, and it's return effect. So it's very similar to React. But as I told you, it's not depends on order. So you can have a conditional for your state. With hooks, you have to follow the conditionals. You cannot have conditionals with state, but here you can have. So it doesn't matter if in what place and in what order I call a state. With SwiftUI, we declare a property state with state annotation. Actually, it's possible to work if you know Swift with a concept of property delegation. It's the new feature of Swift, of the latest Swift. So it also could be observable for us, and it works good, and it makes it observable. And as you see, when we have a state for SwiftUI, we have items, so it's a list. So when we append some item, it's called rendering. So it called rendering of our tree. It's also the same for Compose. So the principle is the same. So when state changes, it call rendering. Yeah, but with list it's a little bit challenges with Compose. It's not, as I told, it's not released, and there is no any kind of list actually right now in Compose. So, but you know, it's, as I told, every node have a key and have a group. So we don't have set a key for every node in the list, like we do in React Native. So there is no any kind of problem with rendering. So, but you know, like as you see on SwiftUI, we have identifiable. You have to follow this. You have to conform this protocol, and you have to have a property ID. It's like a key in React Native. So you have to follow some rules, and it's I don't know, like if Compost will do some optimization. I don't know in what stage they are with list, but yeah, but SwiftUI actually do many stuff right now with components. They have a lot of components to compare to Compost. So Compost only have little bit components. It's just a proof of concept. So and as we see, we use a list and we use iterate in items, and we create items in Compost. We also it's different, yeah, because the example on the left, I don't use a model for items because actually I don't have to use a key. So I just want to simplify, and I only use a counter, and I only iterate and render the same item with the same title, with static title, and just change index. But for Swift, I have to create a model because I have to have ID. I pass this model to list. So yeah, it's more complicated example. As I mentioned, Compost has less boilerplate code. But yeah, let's just take a look because I didn't compare where is the more lines of code. Yeah, I think like maybe there is the same, but you have to write. Yeah, they're the same because I move a rendering in another function in Compost, so actually I cannot compare a line of codes here. And also SwiftUI have very good components, and list, for example, it works good right now. So I think I can compare just line of codes, but if you see on SwiftUI, it has a boilerplate code with conform view protocol, have property body, so everything is generated for you in Compost. But as you saw, SwiftUI has already good tools and documentation. You can use hot reloading and many stuff. But also it's not unfair to compare Compost and SwiftUI right now because Compost it's only proof of concept. But we could actually see what we'll expect. Here is the QR code for SwiftUI samples. You can find games like 20, 40, 48, to-do list, shopping app, many other examples. So it's very useful link. I don't know, you can, before you can find the presentation and download these examples. And what the idea that I start my talk was, like we as React Native developers and Flutter developers actually could write Android and iOS without many problem and with the same understanding how to build application. So for me, for example, I didn't have many experience in iOS, but when I touch a SwiftUI, I thought like, it's like a Compost, like a React Native, so it's not so difficult, and you could create from scratch some iOS application, and it's very good. And the same thing for people who is Android developers or iOS developers. You can start to use React Native. you can join. You can join. I know you can join. In Wix, we really use React Native. Very many code base. A lot of stuff. So we create many libraries, and actually, yeah, it's become more simple to join a React Native team for Android and iOS developers. So thank you.